Hey, Radians here. In this video, we'll dive into the development of a to-do list feature for the productivity app Increaser. We'll cover a range of topics, including backend setup, responsive UI design, drag and drop functionality, visualization of completed tasks, and deadline management. Our aim is to build this feature without relying on external component libraries, demonstrating how to create a custom solution from scratch. While the Increaser codebase is private, we've made all reusable components, utilities, and hooks available in the Radian Kit repository. Throughout this video, we'll provide a detailed explanation of Increaser-specific code, giving you insights into how we approach this development challenge. Before we dive into the technical details, let's take a moment to outline the features we aim to include in our to-do list and the reasons behind them. Increaser is a productivity platform designed for remote workers, offering tools like a focus timer, habit tracker, time tracker, and scheduler. By adding a to-do list feature, we are aiming to enhance its functionality, making Increaser a comprehensive productivity hub. However, designing an effective to-do list comes with its own set of challenges. Instead of replicating the extensive features of established to-do list apps like Todoist, our focus is on identifying and refining core features that cater to the majority of use cases. This approach allows us to focus on delivering a to-do list that is both practical and user-friendly, aligning with the overall mission of Increaser to enhance productivity. Here is a concise overview of the planned features. First, we have deadline categorization, where tasks are divided into 4 groups: today, tomorrow, this week, and next week. This approach strikes a balance between user needs and UI simplicity, avoiding the complexity of more intricate scheduling systems. Next, there is efficient task addition. The Add Task button under each deadline category allows for quick task entry. User can add tasks subsequently by pressing the Enter key, facilitating rapid task addition without unnecessary clicks. Then we have flexible task management. The interface design enables easy reassignment of tasks between different time frames and prioritization within categories, enhancing organizational flexibility. We also provide mobile accessibility to facilitate task management on the go. Another feature is automatic task cleanup. Completed tasks are moved to a separate section and automatically removed at the beginning of the next week, maintaining a clean interface. Finally, we have streamlined task editing. Users can simply click on a task to edit its name, minimizing the need for additional interactions. The task entity has the following structure. It has a started at field, which is the timestamp of when the task was created. There is also an ID field, which is a unique identifier for the task. The name field represents the name of the task. The completed at field is the timestamp of when the task was completed, or it's null if the task is incomplete. There is a deadline at field, which is the timestamp of the task deadline. Lastly, there is an order field, which represents the order of the task within its category. Increaser's API takes a unique approach, deviating from traditional RESTful and GraphQL paradigms. For those interested in backend development, this could be a fascinating area to explore, as discussed in our previous YouTube video. To manage tasks, we use 3 resolvers: create task, update task, and delete task. Each resolver serves as a straightforward wrapper around the task's DB module, which handles direct interactions with the database. Take the update task resolver as an example. It's designed to accept an ID and a fields object containing the updates. Internally, the corresponding function within the TaskDB module retrieves a specific task from the user's items using a projection expression. It then merges the incoming fields with the existing task data before invoking the putTask function. This function is responsible for updating the task in the database by reassigning it with its unique ID. The organized tasks function is key to keeping the to-do list clean. It automatically filters out tasks completed before the current week start. If this changes the task count, the user's task field in the database gets updated. To save resources and avoid extra costs from cron job, this function triggers on a user query request. Let's dive into the front-end implementation details. Our application increaser is built as a static site generation application using Next.js. We've created a specific page for the to-do list feature, which we can access via the tasks route. To separate completed tasks from the active to-do list, we provide a seamless user experience by allowing users to toggle between these two views. We achieve this using the getViewSetup utility. This utility simplifies view state management by taking the default view and a name for the view as arguments. It returns a provider, a hook, and a render function. The provider makes the view state accessible throughout the component tree, while the hook allows component to access and update the current view. The render function dynamically displays the appropriate view based on the current state, ensuring efficient rendering. This setup streamlines the management of multiple views in the code, enhancing both the maintainability and readability of the view-related logic. Our tasks view supports two states, to do and done, with to do set as the default view, amply named tasks. The task view selector component is responsible for rendering the view selector, enabling users to toggle between these two states. Meanwhile, the page title navigation component is employed to integrate the view selector into the UI. The page title navigation component is designed to mirror the appearance of a page title in other sections by embedding it within the page title component. This parent component sets the text size, weight, and color, ensuring that the page title navigation component maintains a consistent look with the titles across the application. The options within the component are displayed in a flexbox layout and separated by a line for clear visual distinction. In our tasks page, the content is neatly contained within a flexbox container that has a maximum width of 520 pixels. This design choice prevents the content from scratching across the entire screen width, enhancing usability. This is especially useful when buttons appear next to to-do items on hover, ensuring a clean and user-friendly interface. Additionally, we integrate the user state only component to ensure that the content is displayed only after user data has been successfully fetched. At Increaser, we use a comprehensive query to retrieve nearly all necessary user data. Also, this query is blocking. Users typically experience negligible delays due to the efficient caching of user data in local storage through React Query. This strategy ensures that the app's functionality is readily available upon subsequent launches, providing a seamless user experience. The Tasks Deadlines Overview widget provides a clear summary of the current and upcoming weeks, showing the start and end dates, the current weekday, and a graphical representation of completed tasks. As tasks are marked as completed, the corresponding circles in the visualization turn green, giving an instant visual indication of progress. To improve the responsiveness of the task deadlines overview, we use the uniform column grid component, which simplifies the creation of CSS grid layouts. This component ensures that all grid columns are of equal width regardless of their content. By setting a mean children width property, it ensures that grid items will wrap to a new row when there isn't enough space to accommodate them in a single line. Additionally, to visually distinguish between the two weeks, we apply backgrounds to the child elements rather than the parent container, creating a clear separation. To categorize tasks into two groups, we first calculate the timestamp for the start of the current week. We then add the duration of 1 week to determine the timestamp for the start of the next week. At Increaser, we often need to convert between different time units, so we use a handy utility called convert duration. This utility takes a value and the units to convert from and to, making the process of time unit conversion straightforward. In the week deadlines overview component, which displays tasks for both the current and upcoming weeks, we provide details such as the week's name, its start and end days, the current date of the week, and a visual representation of task completion. Completed tasks are indicated by green circles, while pending tasks are represented by gray circles. These circles are rendered by the task status styled component, where the completed property determines the color. The design of this component utilizes the round and same dimensions utilities to ensure that each circle is perfectly round and uniformly sized respectively. Depending on the user's selected view, the application dynamically switches between the tasks to do and tasks done components. Rather than using a hook to determine the current view, we employ the render task view component. This approach streamlines the process, enabling render task view to directly render the appropriate component based on the current state, thereby improving code readability. To ensure our to-do list feature is accessible on mobile devices, we check for hover support using the hover and pointer media queries. If a device supports hover, we enable a hoverable drag handle, a small vertical bar on the left side of each task item. Additionally, buttons for changing the deadline and deleting a task are positioned on the opposite side of a to-do item. Conversely, on mobile devices that do not support hover, the drag handle remains visible constantly and a more button is introduced. This button activates a slide over panel for task management, optimizing the user interface for touch interactions. To categorize tasks based on their deadline status, our implementation relies on two key functions: get deadline types and get deadline status. This function helps in identifying the type of deadlines by examining the current weekday. Specifically, on Saturdays, we exclude the this week category from our deadline types. This adjustment is due to the fact that only today and tomorrow remain as viable deadline categories for the current week, ensuring our task grouping logic accurately reflects the time-sensitive nature of task completion. The getDeadlineStatus function categorizes tasks by their deadlines, taking a timestamp for the deadline and the current time as inputs. It returns a status corresponding to deadline type with an additional overdue status for past deadlines. Specifically, it returns overdue for deadlines in the past week. Today for deadline set for the current day, tomorrow for deadline set for the next day, this week for deadlines within the current week, and next week for deadlines falling in the following week. To categorize tasks by their respective deadlines, we implement a systematic approach using two utility functions. The process begins with the getRecord function, which converts an array of tasks into a record format. This conversion segregates tasks into distinct categories or buckets based on their deadline types. Following this, we utilize the recordMap function to process the generated record by turning each value into an empty array. Next, we merge empty buckets with tasks organized into groups based on their deadline status. This process is facilitated by the groupItems function, which accepts an array of tasks and a function to extract the deadline status from each task. The function then returns a record of tasks categorized by their deadline status. With the task groups prepared, we can now focus on implementing drag-and-drop functionality. For this, we use the React Beautiful DND library. The choice of this library is based on my previous experience and its straightforwardness for common drag-and-drop scenarios between buckets. Since React Beautiful DND is not a core library, we choose not to include it in the Rising Kit template. Instead, we'll keep the drag-and-drop logic in the Includer codebase adjacent to our task-to-do component. It's important to know that we don't use React Beautiful DND directly in the tasks-to-do component. Instead, we utilize a custom DND groups component, which acts as a wrapper around React Beautiful DND. This approach allows us to easily replace React Beautiful DND with another library if needed, as the consumer of the DND groups component is unaware of the underlying library and simply implements the required interface. Another reason for keeping the drag-and-drop related code in a separate component is to maintain the readability and understandability of our tasks-to-do component. Mixing drag-and-drop logic with the business logic of the to-do list would make the component overly complex. The DND groups component requires several props. It needs a groups prop, which is a record of items grouped by a key, in our case the deadline status. There's also a getGroupOrder function to determine the order of groups, with the overdue group being the first and the next week group being the last. The getItemOrder function determines the order of items within a group, sorting tasks within each deadline status group. The getItemID function determines the unique identifier of an item, which in our case would be the task ID. The onChange function handles changes in item order and group. Lastly, there are renderGroup and renderItem functions to render a group and an item respectively. First, we maintain the ID of the currently dragged item in the state. This allows us to disable dragging for other items while one item is being dragged, ensuring that other items won't display the drag handle on hover. When the drag ends, we check if the destination or the index has changed from the source. If there is a change, we calculate the new order using the getNewOrder utility function and call the onChange function with the new order and the group ID. The order field is used solely to sort items within a group, and its actual value is arbitrary as long as it's unique within the group. By utilizing the order field, we only need to update a single task in the database when the order changes instead of reordering all the tasks. The logic within the getNewOrder function is straightforward. When it's the only item within a group, we return 0. If the destination index is 0, we return the order of the first item -1. If the destination index is the last index, we return the order of the last item +1. Otherwise, we calculate the new order based on the previous and next item's orders, placing the dragged item between them. To sort the groups and items within the groups, we use the order utility function. This function accepts an array of items and a function to extract the order value from each item. It then sorts the items accordingly to the specified order, which can be either ascending or descending. Both the render group and render items functions receive props and a ref, which should be propagated to the corresponding task list and task items respectively. This ensures that the droppable and draggable components are aware of the underlying DOM elements, allowing the drag and drop functionality to work as expected. Now let's examine how the task-to-do component leverages the D&D group component to implement drag and drop functionality for tasks. We pass tasks that are already grouped into deadline buckets to the group's prop. To determine the order of the groups, we simply use the index of the deadline status in the deadline statuses array. The getItemID function accesses the task ID, while the getItemOrder function retrieves the order of the task. The onChange function is responsible for calling the API to update the task order and deadline type. We render each group within a vertical flexbox, which includes a title, a list of tasks provided by the content prop, and a prompt to create a new task. The renderItem function is responsible for rendering each task item, including the drag handle and the task itself. In the onChange callback, we need to convert the group ID into a deadline timestamp. We achieve this by using the getDeadlineAdd utility function. This function takes the deadline type and the current timestamp as inputs and returns the timestamp for the deadline. After determining the timestamp, we call the updateTask mutation to update the task's order and deadline timestamp. When rendering a task, we must consider whether it is on a mobile device. If it is, we keep the handle always visible by displaying it next to the task within a horizontal flexbox container. If hover is enabled, we employ the onHoverDrag component, which changes the opacity of the drag handle based on the hover state and the isDragging prop. If hover is not enabled, we use the drag container component, which always displays the drag handle. To make the task entity accessible to all children within the task item component without resorting to deep prop drilling, we use the currentTaskProvider component. This component leverages the getValueProviderSetup utility function to create lightweight context providers that serve the sole purpose of maintaining a single value. Within the task item component, we use the useCurrentTask hook to access the current task. We apply the same pattern to check if hover is enabled. Based on that, we either display the Manage Deadline and Delete Task buttons on hover, or show the More button that will trigger the slide over panel on mobile devices. We display the content within the task item frame component, which defines the shape of the task item. This component is also used for the Create Task button and the inline form for task creation. By using such frame components, we ensure a consistent look and feel across the application. To create a checkbox, we leverage a native HTML checkbox, which is hidden from the user but still functional. It will trigger the onChange event when the user clicks on the check component, which is rendered as a label element. The checkStatus component is a reusable component for creating checkbox-like elements used in checklists and form fields. It has different styles based on the isChecked and isInteractive props. By using aspect ratio together with width 100%, we make the component a square that covers the available space. In the case of our task item frame, it will cover the entire width of the task item frame's first column. After the checkbox, we display the editable task name, a component that allows the user to edit the task name. To avoid spamming our API with requests for every keystroke, we use the input depends component. The input depends component receives value and unchanged props, but also keeps track of the current value in the local state. When the user types, the unchanged function is called with the new value, but the actual update is delayed by 300 milliseconds. The user won't notice the delay because the local state holds the value and the input is updated immediately. The manage task deadline component handles the logic for providing the current deadline and calling the API, but the actual rendering is determined by the consumer. Thus, on desktop, we'll display a drop-down, and on mobile, we'll display a slide-over panel. When changing the deadline, we also need to update the task's order so that the task is placed last in the new group. On mobile, we display the options for deadlines together with the delete task button within a bottom slide-over component. Here we use the same manage task deadline component, but instead of a drop-down, it will be a list of menu options. The opener component is a wrapper around the useState hook, which makes the code more readable and easier to maintain. As we cover the tasks in the to-do list, let's check how the tasks are being created. As we saw before, each bucket of tasks, except for the overdue basket, has the create task component at the bottom. It receives an order and a deadline tab as props so that it can create a new task in the right bucket and position it last. The create task component will first display the add task button, and when clicked, it will display the create task form component. As we mentioned before, both the add task button and the create task form components are wrapped in the task item frame component, which ensures a consistent look and feel across the application. Similar to the checkbox, we use a container with an aspect ratio of 1:1 to ensure that the icon takes the same size as other elements rendered within the task item frame. To make the hover effect appear wider than the element itself, we use the hoverable component. The create task form is a straightforward form with a single input field. The bucket is already predefined by the location of the task creation prompt. Both on form submit and blur, we check if the input is empty, and if not, we create a new task and reset the input. Since there is autofocus on the input, the user can create tasks one after another without the need to click any buttons. As we are setting an ID for the task on the front end and performing an optimistic update by updating the state before the API call is resolved, the user will see the task appear instantly. The final piece of our feature is the view with completed tasks. Here we filter the tasks by checking for the presence of the completed add field. Based on the presence of completed tasks, we either display a message at the top of the list indicating that the completed task will be shown here, or a message that completed task will be cleared each week. We then display the task in the same way as in the to-do list, but without the drag and drop functionality. That's all. If you liked the video, please like and subscribe.